The universe is vast and mysterious. It's filled with stars, planets, and galaxies. But have you ever wondered where it all came from? How did it all begin? The answer, most scientists believe, is the Big Bang. Imagine the smallest thing you can possibly think of, even smaller than an atom. Now imagine all the matter and energy in the entire universe squeezed into that tiny point. This incredibly hot and dense point is what we call a singularity. The Big Bang wasn't an explosion in space like fireworks. It was the expansion of space itself. It's like blowing up a balloon. As you blow into it, the rubber stretches and gets bigger, carrying everything on its surface along with it. In a fraction of a second, the universe expanded from that tiny point to an enormous size. This rapid expansion is still happening today, billions of years later. As the universe expanded, it also cooled down. Think about steam coming from a boiling kettle. Close to the spout, the steam is very hot, but as it spreads out, it cools and becomes tiny water droplets. In the early universe, energy turned into matter. This happened because of Einstein's famous equation, E equals mc squared. Energy and mass are really just different forms of the same thing. At first, the universe was too hot for atoms to exist. There were only tiny particles zipping around at incredible speeds. But as the universe cooled, these particles slowed down and started to clump together. This clumping eventually formed the first protons and neutrons, the building blocks of atoms. The universe continued to cool and expand, eventually allowing electrons to join these protons and neutrons. This is how the first atoms of hydrogen and helium formed, the simplest elements in the universe. Gravity is a force that pulls things together. It's what makes apples fall to the ground and the Earth orbit the sun. In the early universe, gravity started to pull together the clouds of hydrogen and helium gas. These clouds became denser and hotter as more gas was pulled in. Eventually, the temperature and pressure at the center of these clouds became so extreme that nuclear fusion began. Nuclear fusion is the process that powers the stars. It's like a giant furnace that releases enormous amounts of energy. When fusion started in the early universe, the first stars were born. These early stars were massive and short-lived. They burned brightly for millions of years before exploding as supernovae. These explosions scattered the elements they had created throughout space, seeding the universe with the ingredients for planets and even life. Gravity continued to shape the universe, pulling stars together to form galaxies. Galaxies are vast collections of stars, gas, dust, and planets. Our own galaxy, the Milky Way, contains billions of stars, and it's just one of billions of galaxies in the observable universe. The Big Bang Theory isn't just a guess. We have evidence to support it. The cosmic microwave background radiation is a faint afterglow of the Big Bang. It's like the heat you feel coming from a stovetop even after you've turned it off. We can also see that galaxies are moving away from each other, which tells us the universe is expanding. And the amount of helium in the universe matches the predictions of the Big Bang Theory. The Big Bang Theory explains a lot about our universe, but it also leaves us with many questions. What came before the Big Bang? What caused it? These are some of the biggest mysteries in science, and we may never know the answers for sure.